Hello everybody, it's Damon. Crazy Logics in most places, Crazy Logics 007 on YouTube. As promised, we're going to work on a Rockford here, an old school one. If you wouldn't believe this, but I'd promised to open this thing up brand new, never before seen to me, so that we could discover it all together. But this is the third time I've had to shoot this video. I picked up another webcam to try to be able to do close-up shots, and had some what appeared to be software problems caused one of my videos to be totally wrecked, and I thought I found the solution online and redid the drivers and stuff to where it was supposed to be all happy and I could do that, and I recorded this all again and it did the same thing, wrecked the whole video. It was all jittery juddery, it was just unwatchable. So third time hopefully is the charm. I've got that webcam completely unhooked. I'll have to do some testing later, try to figure out if it's the webcam or just something I ain't got quite right in the setup. So anyway, let's take this Rockford amp. I think this is a 400.4 based on what's on the board. But it doesn't have a label out here, and there's no label underneath. You'll see here in a minute. I've got all the screws out kind of so we can take this apart, so it's not a brand new open up. Sorry, I'll try to act surprised. But let's start with what you need to do. If you've got an old school amp, or you're going to buy any amp, and if you can't test it, there's a few, if you can't see it playing or hook it up in your vehicle to make sure it works, there's a few things you can do to help alleviate yourself. And then this is also the troubleshooting to figure out what's wrong with an amp when you have a known bad one. So the first thing we do is we look at all of the speaker terminals and stuff. And something I noticed right off the bat when this was a buddy gave this to me, said he didn't know if it worked or not. He wanted me to bench test it, make sure everything was cool. So the first thing I noticed is it was missing Allen head screws for the terminals here. So I'm assuming that this thing's been ran in bridged mode on both, the front and the rear. It was also missing its B plus, I think it is. Yeah, B plus set screw. So I grabbed one to stick in there so we'd be able to hook up power eventually to this. But look in there for strands of wire, all that stuff. Get that cleaned out. Make sure that you're be able to measure good and that you don't get those fine strands of wire always find their way inside of amps and short and blow stuff up. Be careful when you're installing, doing all that stuff. Keep that clean. The other thing you need to do is run all the switches, run them back and forth, turn all the gain knobs, make sure that's good. Look down inside all the RCAs and inspect them, make sure there's nothing broke off inside there. That is a huge problem. I know there's been an issue here on this one, and you would have seen it if the screws had been here. There were non-factory screws here in the holding this RCA's on, and this RCA, the plastic part and stuff, looks like it's taken a bit of a beating, and when those screws were removed, this thing kind of tilted back. So we know there's been a little bit of something there. So that tells us, watch out. It's got its good screw hole here, but the screw hole here, apparently they broke off and somebody tried to drill it, failed. So this one doesn't have its end caps. But we take something between 100 to 300, maybe 400 ohm resistor. This one's a 5 watt. Get a decent size, at least 2, 3, 4. I like 5 watt. Put it on the battery terminals. Another thing on these style of Rockfords is this remote turn-on terminal, which is going to look like one of these. For a fast on, you need to give it a wiggle and make sure it's okay if you're buying one of these or something. But what you're doing here when you put this resistor between the positive and negative is you're draining the filter caps on the input side. There's going to be two main sets of caps inside this amplifier. Filter caps on the power in, and then after it goes through all the power supply section, there's going to be rail caps, which help smooth out and make the rail voltage for the output section to give you the voltage to run this thing at. So we drain that down, and we take our multimeter, and this junk on the board here is important. This is thermal compound, and I want to talk to you about that here in a moment. But before we do the test, go to the tar amps repair video number 3. Look, I show a whole bunch of the other Rockfords that we can repair. vote down in the comments section. They're listed in the description. I show them in the video so you can see each one. In case you need a visual reference, just watch that video. And then vote in the comments for which one you'd like to see me pull apart next, because we've got a couple different old Rockfords, and everybody seems to be excited about Rockfords. I've get a lot of responses on Facebook from it. So anyway, you want to have your meter in continuity mode where it beeps when you touch it. You're going to make sure you got them in the correct spots, because you're going to want to put these in the positive and the negative places. And so we're going to watch our meter go up. We can actually do it right here on the set screws, and watch it go up to a 1. And you notice we didn't get no problems. It charged all the way up. If it had beeped, or if it had stopped at a number, beep means there's a dead short in the power supply for certain. If it stopped at a number, that means we got some kind of short or leakage in the power supply section. That's not going to let those caps fully charge, because your little meter only puts out like maybe a max 3 volts that it's going to be doing that with, and leaky components in the power supply will keep that 3 volts from charging those up. So like I said, you've done your inspection, you maybe found a few things we already know. These RCAs may have taken a hit. We know that the power supply seems okay, so we would flip this amp over. Like I said, this amp has been around the block. Got more thermal compound falling out of it, and this is critically important. We're going to talk about this. If you go to take screws, especially out of all the older Rockfords, they are carbon steel screws into aluminum blocks. They like to rust. Those things like to get bound up in the aluminum. You need to try to tighten it a little bit and then back it off, and be very gentle taking all the screws out. If you need to put a little PB blaster or a little WD-40 or whatever to lubricate them to get them out safely, that's super important. It's extremely hard to get broke off screws out of these steel screws out of these aluminum heat sinks, and if you break one off, you're going to be sad. That's especially true on the old Rockfords, like the 30, 45, 75, and 150s that had them in from the sides. They would really bad, because people like to spray paint those, and so now not only do you have a little bit of rust onto a steel screw into aluminum, but you got spray paint holding it on too, and people will snap them off, and if you don't have the right machining tools and ways to do it, it could be a real booger to get out. You can really make your amp ugly. But so we've taken the screws out of this one already. And like I said, this is the 3rd time. You pick this up from this and you slide it out over the RCAs. Here is the baggie I had that's got all the screws. I get a bag for it, or a little container to put all the screws, depending on when you're working on it and stuff. So I'm going to leave this like this. So here is that remote turn on. This is the long style. It's a 800 thousandths of an inch. Here is the short style. Notice both on the long and the short, it only has 2 little tiny pegs that go through the circuit board to hold it in. And so if this gets plugged in a whole lot and stuff, and people knock it around, the amp's not secure or whatever, and it gets tugged on, these will break off from the board, get pulled out of the board, all kinds of bad things. So I make little pieces of plastic, and you got to make them in different size for different Rockfords. But they'll just be a little square chunk of plastic, and we'll sand it and clean it up and make it look pretty. I've just rough cut these. And you put a little slot in it, and that little slot, and once you've got it sized right, depending on what all's around it, is going to allow you to put this around. See if you can see that, where I can hold it around this thing, and we're going to glue it down with a little E6000. That's going to provide some side-to-side and other support, so that if something does happen, those don't get broke off. Like I said, I've got these were pretty easy to find. I have not found the long ones, so putting that little extra support, it's hidden, it's covered up, you know, nobody can ever see it, but it's a nice little safety thing to keep those from getting broke. There's other ways to do it that are more involved, but the little chunk of plastic and some E6000 gives it some nice support. So got the amp. So remember I told you there was input capacitors. This is what we checked when we first did that thing, was these 4 little caps right here. Notice they got nice silver tops. You're going to want to inspect your big caps, and maybe even some of your little caps out here. These ones with the crosses in them, those are so that if it swells and pops, it does it where here, and so you can see it. So we want to inspect those and make sure those are not swollen, or they don't have, now it can have some dirt and debris in there, but if it cracks open ever so slightly, you'll see what looks like a yellow nasty liquid, and you can also smell it. It'll smell like ammonia or old cat pee, because that's what part of the electrolytics is based off of. Now when you get to, and here's a good thing, I always look at the bottom of the case. You can see I've touched this several times, but you can see where the 4 caps were and stuff, but you're looking for any arcs and sparks that might have shown up. That sometimes helps do stuff, but this is where those caps are. If they have the plastic cap, is because they set up high enough that they might be, if somebody was to flex that base, they could touch the cap top, and if it was under power, those can actually transfer a charge and short out. When you have these black caps, you need to push down on them and make sure that they sink down and that it feels like you have a flat cap, just like this, because if we was to cut the shrink wrap off and pull the top off, you will be able to see, and I don't think, no, I don't have an example. I'll try to save an example and throw in one of the videos of what it looks like. It looks just like this underneath, but that way you know these aren't swole up and expanded, and you're going to want to look around your board. Now this looks like maybe it's been damp or something. You know, this is the serial number thing. That can be just from age. Kind of want to feel it, make sure it's not oily or nothing. Any kind of visual indicators, you know, like that label, telling you that things might have happened to this amp. Helps out. So that's a check real quick. So now we're going to look at the numbers that are on all these FETs, and these FETs in these older, in several different older Rockfords, are on the MEHSA, and I call it Mesha, but that's swapping the S and the H, but we'll just call it Mesha for now. If somebody's got a better pronunciation, put it in the comments and maybe I'll correct myself. But these are really, really difficult to unsolder. This FET is actually soldered right to it, just like you can see there. You know, maybe I should be pointing over here. And if you ain't got the proper tools and the time and the patience to do this right, and I'm going to show you how I do it in the second video, but you can mess these up, and these are no longer manufactured. The only way you can find it is to find a spare parts amp. And if you mess it up, it's ruined, and you have to basically redo this whole section and rechange the way it's all mounted and drill extra holes and make your own aluminum brackets and stuff for holding things down if you can't use this, because this is not only part of the thermal management and helps transfer heat to the thing, it is also the insulator that keeps the backs of all these FETs from being shorted to the case, and it's pretty delicate. Pretty cool design, because when the amp is out of the case, it gives you a little bit of a heat sink, which is nice for some quick testing. You know, it helps drain a little bit of heat, but because a lot of people didn't know what they were doing, they have wrecked these mesh strips and ruined amps because of it. So I'll show you how I do it. I highly caution you, if you're going to try any of it, I'll tell you about, you know, you can cut the legs, you can do other stuff, but that'll be in video too, because we'll actually be removing these 4. So if you read the part numbers off of them, you're going to find these are 5N050s, 5N050, 5N050, 5N050. Then the next thing you get is a U1620 and a U1620R. So these are FETs, and if you looked them up their data sheet, you'd find out they're FETs. The U1620 and the U1620R are diode packs or rectifiers, and the 1620 is with the diodes one way, and the 1620R is with the diodes the other way. I'd have to look them up to tell you exactly, but if you look them up, you'll find out. So that's the rectifier packs. You have an LM317 and an LM337. The LM317 and the LM337 are adjustable voltage regulators, and so there's going to be a few extra components on the board here that is setting what voltage these make. But these two are going to be making off the rail voltage once we get up to rail voltage. So 12 volts in, power supply, is ran by this little TL494 chip. It switches back and forth through this up to this transformer. The transformer steps up the voltage, the rectifiers rectify it, the rail caps smooth it, and then you have rail voltage for your outputs out here to use to drive the speaker terminals. This section up here is the input section, but what these two voltage regulators, they're going to make plus and minus 15 volts basically, and that's two for on this input section, and all the bass and gain knobs and stuff are to run these little op amps. They need plus and minus voltage, and they work best off of plus and minus 15. But you see there's a ton of them there for adjusting each channel, all on this input section, and that's what those are doing. And then we come up to, here's an IRF 9540 and an IRF 540, then another 9540 and another 540. And we got the same thing over here. So if you look those up, you'll find the 9540 is a PNP FET, and the IRF 540 is an NPN. So here's your positive and negative to help make the push-pull on the wave for the output. So we got one pair, we got another pair, we got a pair, we got another pair to go out. So that's where your four different channels are. So that little test is supposed to tell us that something in here in this little section, and maybe these are okay to maybe put power, but we're not 100% certain. I don't like putting power until I've went through and tested all of them. So to test a FET in an amplifier, we keep it on diode mode. And if you have metal backs like these are, see how these are all nice shiny metal tabs? Not all FETs are. The center leg will be connected with that back tab. So it's kind of nice because you can just cheat and put your probe here and touch the outer leg and the other outer leg. And if there's no beep, then you want to do it both outer legs. And we're just looking for a beep. We're looking for dead shorts. So we do that and that. Now you cannot do that to the diode packs. If you touch the outside legs of the diode packs, you're going to get a constant beep because of the way they're wired into the circuit. What you want to do is you want to go from the outside, and if you get a little chirp beep, that's it charging the caps. And then you might get a long beep where it recharges them backwards, depending on how you put it on there. But that's fine. We just want to see it go up, and it's actually going to check like a pair of diodes in there if you look up how to check diodes with your diode checker. But that means that's not shorted. We want to make sure there's no short on the voltage regulators, because that would be bad. And they all seem good. And then we're going to go out to the output FETs, and we can do the same thing on the output FETs. And once you've figured out the little pattern kind of to it, where you're just checking, we have from the middle leg, which remember I was on here, we got a short. That's not good. We got a short here. And we got a short there. And we got a short there. So you'll notice I put a little dot of silver paint here. Like I said, I made this crazy video this is the third time. So I already knew we had some. So this set of outputs over here has probably been blown. Remember we said we noticed the set screws, so they were probably running at bridge. So this one was bridge. Something happened. They shorted speaker wires together. They blew a sub. They just ran it too hard, and they have popped those channels. So we're going to need to remove these FETs. So you can do a couple different things. You can cut these legs and then desolder each one of these individually. And pull them out and then work on the mesh strip. You can desolder all the legs or cut all the legs, depending on what's blown, to try to get that out and do it. Like I said, second video, we're going to focus on how these mesh strips are. But in the second video, we'll yank those four out. And then we shouldn't have any shorts, assuming nothing's really blown in the driver circuits for those here. We should be able to put some power, and I'll show you how a Rockford with just ground and remote hooked up, and you put a little power to remote, the TL494 will make the gate drives, the nice little square waves on the power supply FETs. And that's a great way to check to make sure that the power supply circuit is running correctly and should be able to make it. Once we've removed what we know of the shorted components then too, we ought to be able to put power in. check and make sure it truly is switching through the FETs good, making rail voltage, and we actually should be able to test these two while these are all taken out. Just very, very gently test it because it'll be out of the heatsink, obviously. So we know we got a problem. We're going to have to fix it. Now I want to talk about this stuff that you see crumbling out of here and why it's important. If you buy a old school amplifier, even if it works perfectly, do not run it. You can run it enough just to do a little quick test and make sure everything's functional, but do not run it. You want to know why? Because the thermal compound, which is supposed to be nice and smooth and thin, gets old and deteriorates in a lot of these old school amps. And when I took this one out, it was all dry and nasty, and you can see I've scraped some of it away, but I still got more. Look at how hard it is. That's supposed to be ooey and gooey, and a nice thin layer on here to help fill in any voids and irregularities and transfer the heat from here to this heatsink. So that is critical. If you look at this amp, not only do you need to dump the heat from all this while it's making power, you have bias transistors that help regulate how these from overheating and being driven too hard. And you even have these little thermal sensors right here that are embedded down in there and rely on that heat compound to get an accurate temperature reading of this thing to make sure that this either shuts down when it gets too hot or to throttle it back so that it doesn't get too hot and end up burning up and blowing up power supply and output FETs and everything else. So if you get an old school and you are going to need to cut the little warranty stickers, you know, that's, who cares if it's got those on there if it's going to die, unless you're hanging it on the wall to look at for pretty. If you want to actually ever use it or anything else, enjoy these amps for what they are, you're going to want to check that thermal compound and clean it all out. And we're going to clean all this up. We'll do that probably in the last video when we've got FETs replaced and we're ready to go back into the case and actually give it a good hard test. But that you will kill your amplifier because it has no way to truly dump the heat from all these that's from rock and roll efficiently into the heatsink. It's going to be doing a much worse job. That hard thermal compound actually is worse than having no compound at all because it's embrittled, it's bracked, it's cracked, sorry, and it's made a whole bunch of waviness to the surface and made more gaps to where it's not as smooth and efficient. So the one final thing on this amp that we're going to note is that, remember we said the screws were not, excuse me, I had a hiccup there. Factory originals. I can see that this is leaning back. I can see there's a little cracked plastic pieces here on the corner. So we're going to have to do a nice inspection of this, maybe fix some solder joints or straighten it up, maybe glue in back some pieces and do a little reinforcing with some E6000 to make sure this is in good shape and got good connection. Could have been something got smacked here and caused a dead short in the RCA setup, which caused this set of channels to drive crazy, and that's what blew these. So we're going to do that. I always recondition the pots and switches with deoxit and make sure they're always all working, and that's important. I'll show you kind of that. Never turn these bias pots. They will not give you any more power. They will just blow up your amp. These have to be set correctly to pre-bias the output FETs, and I will show you how to do that. We're going to crank this since these are the bad FETs, and we'll be putting new FETs in. This is the pot that matches this circuitry to whatever FETs are in here, so the new ones will have to be matched. So we turn these all the way down, and there's two different ways you can set the bias on it. One's through current, and one's through voltage on these emitter resistors. And we'll show how to do that, just so you know. But don't think you're going to get any more power out of this amp by turning these up. All you'll do is blow it, just insta-blow it. These are not a power adjustment. These are a bias adjustment. And they're just to make sure that these things turn on and off properly and don't get overdriven and blow up. So not extra power. Okay. I'm probably not as enthusiastic doing this one, sorry, since this is the third time I'm having to do it. I'll be more energetic when we go to do this next video here. But hopefully that showed you how to check some things. If you go to buy a used amp, you know not to run it except for just a quick test. Inspect your stuff for your thermal compound and stuff. How to check some FETs inside to make sure if you're buying something, you know, you're not buying a blown up, you know, especially if you can't test it. And then if you do have one that's broke, you know, you can start narrowing down where the problem is. We've narrowed down that we at least have a problem here. We want to check this out because we've seen the damage here before we try to run anything over there, and actually before we try to run this other side. But I'll show you all of it. I'm going to try to show every bit of the troubleshooting with the multimeter, which we've done there. I will show you a few things on the scope. As long as only these popped and it didn't hurt anything in the drivers, except for maybe we'll check several things here and I'll show you with the meter. But as long as it didn't really do any other damage and we get super lucky and it's just kind of a replacement one of these, I'll show you how to do that. We also got to make sure these bias resistor legs aren't touching this mesh strip because there's conductive areas there, and that'll short that out and wreck that channel. So that on all those, I'll show you what I do. But as long as we got lucky, you know, and on a different style amp that doesn't use these mesh connectors, you could find yourself replacing, and you need to, if these were all the same because it was a 2-channel amp or something, you need to make them all matched. So you'd order, like if this was just a 2-channel and these were all one side style and this was another, you'd want to order a batch of 4. But I've got 4 new replacements. I match whenever I do bridgeable channels, even so that since they're going to be working in together, if somebody bridges it, I'll just put all 4 new components, even if when we take these out, if only this one's blown and this one's blown and the fact that they're blown is making these show goofy, I don't reuse these ones that have ever been there. I'll save them and I'll leave them marked like this, and that's my little mark that tells me that these are out of an amplifier that was blown, and I put them in my spare parts drawer that's for testing, so that sometimes if I think I've repaired a drive circuit out here, but it may blow something up, I'll put things like this back in that are sacrificial, that are not good, brand new, to do a couple tests, and if it's fine, then I'll yank them out and put all the nice brand news and everything. If these are totally bad, then I put a big old silver X on it, and that way when it's laying here on my workbench, when I'm all done, I know which ones to chuck and throw away. But if they've just got a little dot on the corner, you know, for me anyway, that those were used and they will not be in an amp that I get rid of or anything. But they were used, and like I said, I save any that end up testing good once they're out of the circuit. We'll definitely have at least 2 dead. They may all 4 be dead. But that way I got a couple test ones, sacrificial ones, instead of putting nice new expensive new ones in and sacrificing them when you're trying to find, you know, little bitty components that might be bad or something that's not driving quite right. So, well, hopefully this gets up and published. Like I said, hopefully 3rd time's a charm. I keep repeating that, but it's been a heck of a go. It's a lot of information really quick. I'll be a little more happy-go-lucky on the next one because hopefully I won't have had done it 3 times. If you learned a little bit, if you like this kind of stuff or you found it informative, you know, likes are cool. I love comments. Give me comments. Don't forget to go to the Tar Amps repair video number 3. Look at all those Rockfords in it and vote in the comments section on that one for which one you want to see next. And then leave comments here. If you got some questions, I'll try to leave a few days to get a few questions maybe off this video to be able to answer in the video where we do the next set. Like I said, lots of comments, great. And you know, if you got buddies that like Old School or like Rockfords, because I got PPIs, sound streams that are my own personal amps that need repaired, a whole bunch of other Zapcos, lots of Old School and lots of new amps that I'm going to be going through. So if you got any interest in this, your buddy's got any interest, you know, subscribe. Tell them, you know, have them come up. We may be doing an amp that you own and that might help you out. And so just stay tuned. I've got tons of them. I've got a big stack of dead amps that I'm just going to keep doing this because I enjoy it. It's fun. This is my hobby, and we'll get this one up and running. Like I said, like, comment, love the comments, and Give me a subscribe if you can, because we're going to have a bunch of fun. We're going to keep doing this for as long as I got amps stacked around. I hope you learned something, and I hope you enjoyed it. And thanks for watching a whole bunch. I'll see you in the next video where we tackle the next problem. Be good.